Let's dive into shift registers, which are digital sequential circuits. We'll cover serial and serial out registers, where data enters and exits one bit at a time, and parallel load registers, where multiple bits are loaded simultaneously. Shift registers are sequential circuits built using flip-flops. They store and shift digital data from one flip-flop to another. Data moves through these stages with each clock pulse. This visual shows a basic shift register with 4 flip-flops, labeled FF1, FF2, FF3, and FF4, connected in a chain. Now let's focus on the serial and serial out or SISO shift register. In this type of register, data flows one bit at a time into and out of the register per clock cycle. The register shifts the data to the right with each clock pulse. You see here the serial input, which goes into flip-flop D0, then to D1, D2, and finally to D3, with the serial output coming from the last flip-flop. Here's how a serial and serial out register operates, using a truth table and example. Initially, all flip-flops Q3, Q2, Q1, and Q0 are set to 0. For our example input sequence 1011, it takes 4 clock cycles for the complete data transfer. Notice that the output appears in reverse order, because the shift register shifts data one bit at a time. Next, we explore the parallel load shift register, which has enhanced functionality. It allows you to load multiple bits simultaneously in parallel mode. This type of register offers fast loading, as all bits are loaded in a single clock cycle. It also operates in dual mode, meaning it can perform both parallel loading and serial shifting. In this parallel load circuit, observe the multiplexer, MUX plus flip-flop configuration. You have parallel inputs D3, D2, D1, and D0, and control signals labeled load and shift. When load equals 1, it's in parallel input mode, and when load equals 0, it's in serial shift mode. The circuit consists of a multiplexer and a flip-flop unit for each bit, allowing data to be loaded in parallel or shifted serially. Here's a table showing the operation modes of a parallel load shift register. In parallel load mode, when load equals 1, all flip-flops load parallel data simultaneously, allowing for instant loading in just one clock cycle. In serial shift mode, when load equals 0, data shifts right one bit at a time with each clock cycle, resulting in gradual data movement. Let's summarize the applications and key differences between shift registers. Shift registers are useful for data transfer, such as serial to parallel conversion, and creating delay lines for generating time delays. They are also used in counters like Ring and Johnson counters, and in memory for temporary data storage. Serial and serial out registers are simple and operate serially, while parallel load registers offer fast loading and versatile dual modes. These registers are fundamental in digital systems and enable efficient data manipulation and transfer. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.